All right, and so the last one I wanted to talk about in 7.3 is some sine and cosines of special angles. And then I have to give you the arc length formula, that's right. But here, these are some special angles that you're going to want to remember. Okay, I already told you about pi over 6 and pi over 3 and pi over 4. These are ones to commit to memory. These should be interchangeable in your brain. Flashcards would help. The way I kind of think about this, when you divide by a larger number, it's smaller, right? So of these three, pi over 6, that's the smallest number, and so that's 30, that's the smallest angle. Pi over 4, that's the one that has a 4 in it, so that's 45, it's also in between the two. And then pi over 3 is 60. Pi over 3 is the biggest chunk of the pizza, right? If you take a pie and cut it into 3. And so that's 60 degrees. And so there are some helpful sine and cosine values to just have in your brain, which are these here. You can just memorize these. However, I would just, that's fine. Some people learn better that way. This is the way I learned it, and I find it to be very helpful. That way I don't have to second guess if I'm remembering the table wrong or something. I just draw this triangle, and I draw it right every time. And so this is how it goes. So it's the same. You remember maybe the 30, 60, 90 triangle. If you don't, that's okay. But this is a special triangle from college algebra that has all these properties, and it's a 1, 2, radical 3 triangle. See the side lengths here, 1, 2, radical 3. And the way I remember how to draw this triangle is the way I remembered the angles. The shorter side gives the smaller angle. So 1 is smaller than radical 3 and smaller than 2. Radical 3 is like 1.4-ish something. Okay, or 1.6, I don't know. But it's bigger than 1. And so the smallest one is across from pi over 6. That's how I remember that. And then the longer side, radical 3, is across from pi over 3, the larger angle, 60 degrees. And then the 2, the hypotenuse, is right across from pi over 2, or the 90-degree angle. So as long as I draw this 1, 2, radical 3 triangle correctly every time, with the side lengths and the angle measures correct, then, as long as you remember SOHCAHTOA, which again is just a thing to help us remember the ratios of the sides, sine is opposite over hypotenuse. Sine of the angle equals opposite over hypotenuse. This is what this piece means. So of the angle, so sine of, let's start with pi over 6. So sine of pi over 6 is opposite over hypotenuse. So that's 1/2. Cosine of pi over 6 is adjacent over hypotenuse. Adjacent over hypotenuse would be radical 3 over 2. So it's radical 3 over 2. And likewise, you can fill out the rest of these entries using that idea. Okay, TOA is tangent opposite over adjacent, so you get 1 over radical 3. And then you can work through each of these other angles just like that. Okay, and then the only other triangle that you should really memorize is the isosceles right triangle, and that's where both of these angles are the same, 45 degrees. So that means that it's isosceles that has 2 of the same sides. So this is a 1, 1, radical 2 triangle. Okay, and you can verify here that, sine of pi over 4 then is opposite over hypotenuse 1 over radical 2, which we often write like this. And you actually might wonder why we do that. This is an okay way to write it, but often people will prefer to convert it to what we call a rationalized form, where we don't have that nasty radical in the bottom. So square root of 2 times square root of 2 is just 2, and then at the top we have that square root of 2, just so we're not dividing by a radical. But in the same way, sine and cosine are these values. Okay, and so this is kind of a geometric way to remember these angles. This might seem like a lot, but over a few days of working with these, it should become pretty familiar. And you're, again, saving yourself time from thinking through this basic stuff later. I don't stress memorization that much, but this is one of those things that can really help kind of grease the wheels.